All right, let's review very quickly. We have learned similarity, we learned proportions. First section, we learned some proportion, what proportion was, how to identify proportions. We also learned how to make sure that we had a scale factor, which we have. And then we learned the last section, 11.2, we learned the three different things that make up similar triangles. Angle, angle, side, and side, side. And there are a bunch of different problems we'll go over in class together. Now, today, we are going to go over similarity of right triangles. So, what's the difference between a regular triangle and a right triangle? A regular triangle, all right, a regular triangle doesn't necessarily have a right angle. It could have any angle. But a right triangle has specifics, gives specifics to it. So therefore, what we're going to learn in this section is how to identify when you have right triangles. So with the right triangle, there's going to be some certain things you're going to know right away. When you have a triangle that is a right triangle. So if I draw a right triangle here, okay, it's a right triangle, okay? And I were to draw an altitude, okay? So let's review back. This is really a long time ago. We talked about altitudes, we talked about medians, we talked about perpendicular bisectors, and we talked about angle bisectors. When we talked about an altitude, what did that do? It would be drawn down and form a 90-degree angle. In other words, I would be drawing this to form a right triangle, correct? Everybody agree with me on that? So, let me ask you this question. If this whole big thing is a right triangle, and I draw an altitude, that would form a right triangle. Now let's think about that for a second. See this big triangle? Everybody see that big triangle there? That would have a congruent angle. What else would it have? If you take this and you think about this for a second, draw that like this. This big triangle is going to have a common angle to that. The big triangle is going to have a common angle to the little triangles. Everybody see that? This angle is going to be the same in the big one and in the little one. So therefore, according to what will those two triangles, the big one and the little one, be similar? Very good. Angle. Well done. So what they're going to say to you is if you see an altitude drawn, then what we will know is that it will form a right triangle. So they're going to give you some information. And how do you know that? Because of angle. Because if it has this angle, right angle, and that angle is similar in both, is congruent in both, therefore it's going to be congruent. Everybody see that? Any questions? Good. So that's the first theorem you need to learn. 11.3.1. And that is altitude. Can't spell altitude. Okay? If it's a right triangle altitude theorem, what is it saying? It is this. If I draw an altitude, it's going to make these into right triangles that are going to be what? Congruent. These two both are going to become right triangles that are similar to the big one. So here's how I remember it. Look carefully. 11.3.1. 11.3.1. One altitude creates three right triangles that are congruent. One altitude, three right triangles. And that's what you needed to remember. Now, the next thing you're going to learn is geometric mean. So when we've learned a mean, and this is not like us being mean to each other. What is mean? Mean is average. And of course, because geometry is always more complicated than any other math, we have what's called geometric mean. Well, let's see. What does geometric mean? Here's what geometric mean is. A over x equals x over b. So just write that down. That's your initial drawing. And I'm going to show you and explain it to you here momentarily. A over x, x over b. So in other words, when we're finding the average of A and B, you're going to do it using this method, which is what our proportions are. So in other words, you're going to end up with x squared A times B, and that's what your answer is going to be if you're looking for x. So watch carefully. If they give you two numbers, like for instance, they say, okay, find the geometric mean of 3 and 27. 3 and 27. Well, what would you do? Your A and your B. So it's going to be 3 over x equals x over 27. Cross multiply. X squared equals 81. Square root, x equals 9. So all you're doing, it's doing the average geometric style. Because of course, we would never do anything easy in geometry. We would always make it a little bit more difficult. So let's try it again. No, let's do it. 6 and 9. Let's find the geometric mean of 6 and 9. So, what are our two fractions? 6 over x, x over 9. Cross multiply, we're left with x squared equals 54. Square root, x equals 3 times the square root of 6. Right? And that's your final answer. All right, and how did I do that? I'll show you, remind you. If I have square root of 54, it's going to be 3 to 18, 3 to 6, 3 to 2. Take twins out and bury them. And you're left with 6 inside the house. Okay? Now, there are two more theorems you need to learn. Two more theorems you need to learn in this lesson. Okay, so, and they will use your geometric mean. Okay? So, here we go. Well, it's actually one, it's just a reverse of the one. All right? It says this. The altitude of the hypothesis of a right triangle divides the hypothesis into two segments. That the length of the altitude is the geometric mean between the length of the two segments. So, let's think about that for a second. So, if I were to draw this, here's what we have, and we draw the altitude, right? It's going to make this hypothesis, okay, this is the hypothesis, right, into two sections, okay? All right, now listen carefully. It says, to the two segments that the length of the altitude, so this distance is going to be the geometric mean of this and this. Okay, so 11.3.1a, okay, is simply going to say that if I have my altitude drawn, it is the geometric mean of A and B. The geometric mean of A and B. All right? So, any questions on that? So, altitude, section A, section B. So, watch carefully if I do a problem for you. I draw the altitude. This is 10 and this is 12. What's the length of my altitude? X over 10, 12 over x. Cross multiply, x squared equals 120. Square root, x equals square root of 120. Let's take it up here so we can do it. 120 divided by 2 is 60. Divided by 2 is 30. Divided by 2 is 15. 3 and 5. So we take out one set of twins is all we can do. What's left in the house is 30. So 2 times the square root of 30 would be the length of the altitude. All right? Good. Now, the second one. So that's the first one. So when you have the altitude is the geometric mean of these two sections. The second theorem you need to learn is this. The altitude to the hypotenuse of the right triangle, it divides it into two segments that will do this. Now listen carefully. That the leg is the geometric mean between the segment of the hypotenuse and the entire hypotenuse. So 11.3.b is a little bit different. So 11.3a says what? That my altitude is what? The geometric mean of the segments. Everybody got that? So 11.3.1b is going to be the leg is the geometric mean, and I'll write it, geometric mean of the segment adjacent and the whole hypotenuse. So I'll show you what that looks like in a second. So here's our drawing, okay? If I'm looking for this leg, okay, my x is now the leg. What you're going to do is the segment, which is the segment adjacent, A or B? The answer is B. The segment adjacent is B. So it's going to be B over x equals. Now it says the whole hypotenuse. What's the whole hypotenuse? What's the whole hypotenuse? X up here, A plus B. So it's the whole hypotenuse is the whole thing. So you add it together. Does that make sense to everybody? So what you're doing is you are combining them. Okay, so there's two different ones. You have three things that talk about the altitude. The first one, the altitude, divides into three right triangles that are going to be all similar. Second one divides the altitude and it forms a geometric mean, and that's how you solve for the length of the altitude. The third one, when you draw the altitude, you're going to find the leg is going to be, x leg is going to be the geometric mean of the section closest and the whole thing. All right? Does that make sense to everybody? So let's do a problem, and then I'll release you to do these on your own, okay? All right? So here we go. Say this is a right or triangle. Here's our hypotenuse. We want to solve for this. And I'm going to say the whole thing is 20, and this side is 5. And we're going to solve for x and y so we can have it practice 2 times. So I want this leg. So first off, well, actually we'll solve for x, y, and z. We'll solve all three, just so we really practice. So if I have y, if I want to solve for y, okay, so there we go. So I need the geometric mean. Now remember, I gave you 3 things to think about. The first one is that if they're cutting at a right angle, then it's going to be a right angle or similar. That doesn't help us in this case. The altitude, we're not looking for the altitude, this is the leg. So can somebody tell me what this leg, which is adjacent, what part of the hypotenuse is adjacent? 5. So we're going to put 5 here. And what's the whole thing? 20. Good. So how would I solve this? X squared equals 5 times 20 is 100. X equals 10, or y equals 10. So far we got one of them being 10. Is everybody good? Now, how would I find x? Well, before I find x, I have to find something. I need the segment that is adjacent. Well, if the whole thing's 20 and this is 5, what's this section? 15, right? 20 minus 15 gives me this section. So, if I want to solve for x, I'm doing a geometric mean again. X and x, so what is adjacent? 15, and the whole thing is 20. 20 times 15 is 300. Good. So square root, x equals the square root of 300, which, I'm going to bring it up here so I can do this so I don't have to bend over. So 300, I can take out 2, right? And that gives me 150. 2, and that gives me 75. 5, and that gives me 25. 5 and 5, right? So I take out my sets of twins, 5s and 2s, right? 15, sorry. So what are we left with? 10 to the square root of 3. So x is equal to 10 times the square root of 3. Now how do I find z? Good question. Remember the other one. The altitude length is the geometric mean, so that's where I put my z's here, of the two sections, 5 and 15. 5 times 15 is 125. And z squared. So what do? Square root, I'm left with 5 times square root of 5 equals z. And there are your 3 answers that you're going to solve for. All right? If you have any questions, feel free to ask on the Zoom. We will begin the process of going over this and making sure you're all on the same page with this. All right? Thanks so much. Talk to you soon. Bye.